Assalamualaikum. We are Group 3 from Section 4. Today we would like to present about Control Lab 1 for Part 2. First of all, my name is Nur Shamini binti Abdulaziz, CE190184. In this lab session, we need to study the transient and steady state response by adding the transfer function to the system. The equation and the block diagram will use the same like in Part 1. It's just adding the transfer function on the over the response, under the response, and critical the response. So I will pass to the next presenter to do some demonstration and explanation.
Hello, my name is Haris Manajiha binti Iriza and my metric number is CE190061. Okay, this is the block diagram of our dam system. In this case, we just add 1 over 6 plus 1 transfer function to the system. The equation for our dam, we just use same like as part before. And then we make a connection from here to here. Then we click 1. After that, we click 1. Okay, just wait a minute for compile. Okay, click scope. Okay, so this is so we can see the abundant graph. So this is the abundant graph. So we can see the abundant graph becomes stable of the static point. Because we add 1 over 6 plus 1 transfer function to stabilize at the end of the reading. Therefore, this abundant graph more stable than the other. Okay, next I'll pass to Muhammad Safi. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So I will be presenting for under dam conditions. Okay, as you can see in the simulation, so as you can see here, for the transfer function equation, we have just used in the previous lab part 1. So the only difference for this presentation is the feedback block diagram, which is below there, which is 1 over s plus 1. Okay, so Zareb, can you please run the graph? And then please click the scope. Okay, as you can see here is in the output graph here on the scope. So in the previous lab, for the under the conditions, for the theoretically the output would be just the same as this, but there is a slight difference in the middle of this, which is in 7 seconds it should be reach a steady state, but for this part, for this under the condition, it's the rise time starts at the maximum rate condition because of the theory for the under dam conditions, which is it will start here on the rise time and slowly gradually the output graph will gradually become small in size until to the end of the time for this graph. Okay, so that is all from me. Thank you. Next, I will pass to Muhammad Azam.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Azam bin Wan Harun, numeric BE190031. Today I want to present about undammed graph. Okay, for here is the simulating like the previous part 1, for the transfer function is 4 4 divide s square plus 4, and it just has the feedback 1 over s plus 1. Okay, Zarid, can you run for me? Okay, then after you run and you tick the scope, here the undamped graph will appear here, and the undamped graph become unstable when the 1 over s plus 1 transfer function is added as seen in the diagram. This graph begins with a consistent reading value. The graph then goes up and down from the time to time till it reach and it become eternally unstable by the end of the reading. Okay, the rise time increase as you ascend, and it continue to increase in value indefinitely. Okay, I will pass to the next presenter, which is Nurul Shahana.
Okay, my name is Nur Shohana binti Azhar, CE190174. Now I'm going to present regarding critically damped response after we added another transfer function into the system. The value of the numerator and numerator must follow the condition of critically damped, which is the value of damping ratio must be equal to 1. So the equation used here is 9 over s squared plus cs plus 9, which is same as the previous equation in part 1. So now we run the block diagram and double click at the scope to see the result. Okay, so according from the result we get here, the critically damped graph becomes stable at settling time due to the condition of the 1 plus s plus 1 transfer function at the end of the reading. This graph characteristic is second place on the stable since it takes longer than underdamped structure. So that's all from me. I'll pass this presentation to the presenter in charge to wrap up the conclusion. Thank you.
As a conclusion, we can see the difference without adding transfer function and with adding transfer function. The transition response have changed dramatically after adding the transfer function to the system. Except for the overdamped response, all transition response are stable after applying the transfer function because the graph grows larger as time approaches infinity. I think that's all for us. Thank you.